I'm going to go through the full problem set, and if you want to just skip to the problem that you wanted to see in the link to this in the answer key, you will have found there were, I put the times that each problem was hit so that you can just jump ahead to the part you need. Otherwise, I'm just going to go through it all. It'll take a little bit. All right, so 3-96, you had part A, which was asking you to find the equation of the line for both of these. So if you had a slope of 0, m equals 0, it passes through the point 6, -11. That's an x and a y. So we're doing y equals mx plus b. There we go. M is 0 times x, and then my b value would be that y-intercept of -11. So the rule here should have been y equals -11. The 0x is just gone. On b, here we need to find the slope and the y-intercept to find the equation of the line. So 12, 12, and 26. So 12, 12, that's my xy, x1, y1, x2, y2. I'm going to use my formula, y2 minus y1 over x2 minus x1. So I'm going to do 6 minus 12 over 20 minus 12 gives me -6 over 8, which is the same as -3/4. And then I need to plug in and solve. So -3/4 x plus b. I'm going to plug in one of my values here. I'll go ahead and use the 12, 12. So 12 equals -3/4 times 12 plus b. So I'm going to multiply here, multiply by 3 and divide by 4. I know that 12 divided by 4 is 3, so really I just need to do -3 times 3. I don't know if that makes sense or not, but that's going to give me -9 plus b. So then I add 9 to both sides, and I get b equals 21. So my rule is y equals -3/4 x plus 21. All right, next. I'm doing 97. 97 is a graphing problem. So I'm going to start by setting up my axes. I won't make you watch that. Now what I've done here is the absolute bare minimum for setting up a graph. You need to have the x and the y and one scale marker on each side. So my first equation is y equals -4x plus 3. So I have a y-intercept of 3 and then a slope of down 4. So that would be 2, 4, and then over 1, down 4, 1, over 1, etc. And then x minus 7. So 2, 4, 6, 7. And then I go up 1, over 1, up 1, over 1. So that's my matching point there. Take a ruler, connect my points. And that was connecting at x equals -5 or x equals 2, y equals -5. So 2, -5 is my intersection point. For 98, for A, all those parentheses, they aren't really doing anything. They just mean that we're multiplying all this stuff together. So x squared times x squared times y to the third is another way to write what's right above. They are the same. So that means that these can combine to be x to the 4th, y to the 3rd. On B, this is the one that a lot of people missed. We have, actually that's not true, sorry. This one was generally fine. X to the 3rd, x squared, y to the 3rd. So we have 3 up here, 2 down here. Those are going to leave me with 1 up top, y to the 4th, y to the 3rd. That'll leave me with 1 up top. So just xy. Then we have C, 2x squared times -3x to the 4th. So 2 times -3 is -6. X squared times x to the 4th is x to the 6th. Then we have D, 2x cubed That means 2 is cubed and the x is cubed because of those parentheses. This is not the same as 2x cubed. This is the same as 8x cubed. Right, next we have on 4-11, they give us this problem right here and then 3 people's possible ways of solving it. So first of all, my apologies. Jorge's strategy of using a generic rectangle. You're actually going to learn about generic rectangles on this Friday. I pulled a problem from later on and didn't read it thoroughly enough. So my bad that you were confused by Jorge and his generic rectangles. He's wrong. Then Cadell thinks it's 8 times 10 to the 10th, but he cannot explain why. Let's try it and see if that's what we get. So I remember I told you that when we're multiplying, we just have to multiply parts, right? So the 2 times 4 gives us 8. And then 10 to the 3rd times 10 to the 7th. Well, multiplying would mean we would add those exponents, so that'd be 8 times 10 to the 10th. So Cadell is correct. Correct. Good job, Cadell. And we can explain why, because he multiplied like parts, perhaps. And Lauren's reasoning was correct, but she did it wrong. She did the exponent laws wrong. Lauren did the exponent laws incorrectly because she multiplied 3 times 7 instead of adding them. Wrong. All right. Finally, on 4-41 for A, we have 5. This is the problem that I saw the most mistakes on, so I'm going to go a little slower through this one. So we had 5 to the 0 times 2 to the negative 3. So 5 to the 0, we remember anything to the power of 0 is 1. And 2 to the negative 3, we can just leave that for right now. 2 to the negative 3. Well, 1 times anything is just itself, so this is just 2 to the negative 3, and I'd prefer if you leave your answers without negative exponents unless it is scientific notation. So we could rewrite that as 1 over 2 to the 3rd, which is the same as 1 over 8. I would accept any of these 3 answers, but this is my preferred one. On B, this is probably the most commonly missed one on this whole assignment. A to the 3rd over B to the negative 2 times AB squared over A to the 4th. I'm going to take this step by step. There's so many different ways you could have done this one because there's so many different steps that need to be done, and any of them can be done in any order. All right, but I'm just going to do it my way. So first of all, we need to make absolutely sure we understand that AB squared really means A times B squared. So I'm just going to rewrite that right off the bat. You could even think about it as A to the 1 times B squared. Okay? Then what I'm going to do is I'm going to start by multiplying my fractions. So that's, well actually no, maybe I'm going to start by doing a single simplifying move. I'm going to just deal with that right now. So my A up top is gone, and I'm left with an A to the 3rd on the bottom. I'll rewrite it so it looks nicer. A to the 3rd, B to the negative 2, that hasn't changed. B squared, A to the 3rd. Okay, now I'm going to do my multiplication. So this is going to give me one big fraction with just the same stuff, because when we multiply fractions, we multiply top by top, bottom by bottom. So A to the 3rd times B squared, A to the 3rd, B squared, and at the bottom, B to the negative 2, A to the 3rd. Okay, now, A to the 3rd, A to the 3rd. Hey look, that makes a 1. Anything divided by itself is a 1. So those are gone. So that gives me B squared over B to the negative 2. I think this is where a lot of people messed up. So here, we are dividing, right? This is a fraction, so it's like a division problem. So I get to subtract my exponents. So this is the same as B squared minus negative 2. Because I get to take this exponent and subtract that one. That gives me, because we know our negatives, that gives me B to the power of And C, we have 2.3 times 10 to the negative 3, and then that's times 4.2 times 10 squared. The first thing I need to do is 2.3 times 4.2. And even though I know a lot of you probably used a calculator for that, I'll do it out just for fun. 2 times 3 gives us 6, 2 times 2 gives us 4, put in a placeholder 0, 4 times 3 is 12, put in a 2, carry a 1, 4 times 2 is 8, plus 1 is 9, put it over there, and then we add those together, 6, 6, 9. So that gives me 9.66 times 10 to the, and then since we're multiplying I get to add those exponents, negative 3 plus 2 gives me negative 1. On D, we're doing 3.5 times 10 to the third squared, which is the same as 3.5 times 10 to the third times 3.5 times 10 to the third. So I'll do the same thing. I'll multiply 3.5 times 3.5. Sorry, I needed more room. So 3.5 times 3.5, 5 times 5 is 25, carry the 2, 5 times 3 is 15, 16, 17. I put in a placeholder 0, 3 times 5 is 15, 5 goes down, carry the 1, 3 times 3 is 9, plus 1 is 10. And I add them up, 5, 12, carry the 1, 2, 1. And my decimal is 1, 2, right there. So now I have 12.25 times 10 to the 6th. However, this is not in correct scientific notation, as you learned from Desmos. So you're going to move the decimal over one spot, 1.225 times 10 to the 7th, because when I make this number smaller, I have to make this number bigger so that it balances out. All right, I hope that was helpful. Let me know if you like this strategy better or the other strategy for going over homework better.